Fire safety training. Hello everyone and welcome. I'm a trainer from Sheogi, Calm. Today we're here to talk about a critical safety topic, fire safety. Fire safety is paramount in any environment. Understanding the basics of fire and how to prevent it can save lives and property. Let's begin by discussing what causes fire. Fire will most likely be caused by the following: poor housekeeping, improper handling of flammable gas or liquid, accumulation of combustible waste, faulty electrical connections, smoking in non-designated smoking areas, use of spark-generating equipment or tools in restricted areas, especially those rich in flammable gas. Now let's look at the fundamental concept behind fire safety, the fire triangle. Fire safety, at its most basic, is based upon the principle of keeping fuel sources and ignition sources separate. Three things must be present at the same time to produce fire. 1. Enough oxygen to sustain combustion. 2. Enough heat to reach ignition temperature. 3. Some fuel or combustible material. Together, these three elements produce the chemical reaction that is fire. The good news is, if you take away any of these things, the fire will be extinguished. Let's break down each element. Oxygen sources include atmosphere, oxygen/air cylinders, compressors and piped systems, ventilation systems, oxidizing chemicals like nitric acid, combustible substances containing oxygen, fuels or ether, combustible solids, flammable liquids, most organic elements such as flammable dusts, flammable gases, flammable liquids, flammable chemicals, electrical equipment, paper, card, wood, plastic, rubber, foam, furniture, textile, fixtures, fittings, and waste materials. Source of ignition/heat includes the following: naked flames, hot surfaces, heaters, smokers, materials, hot works, mechanical and electrical sources, igniting chemicals. Understanding fire classifications is crucial for selecting the correct extinguishing agent. We'll look at both US and EU classifications. Classification of fire, US. Class A involves common combustible materials like wood, paper, cloth, etc. Class B involves flammable liquids such as gasoline, paints, and solvents. Class C involves live electrical equipment like computers, panels, and machines. Class D involves combustible metals like magnesium, lithium, and titanium. Class K involves cooking media, specifically cooking oil and fat. Classification of fire, EU. Class A involves common combustible materials like wood, paper, cloth, etc. Class B involves flammable liquids such as gasoline, paints, and solvents. Class C involves flammable gases like butane and methane. Class D involves combustible metals like magnesium, lithium, and titanium. Class E involves live electrical equipment like computers, panels, and machines. Class F involves cooking oil or fats. Let's dive deeper into Class A and B fires. Class of fires involve ordinary combustible materials: wood, paper, trash, plastic, and cloth. These fires are usually relatively slow in their initial development and growth. Because these materials are solids, they are somewhat easier to contain. Class of fires leave an ash after the material has been consumed. Class B fires involve flammable and combustible liquids and flammable gases such as gasoline, fuel oil, paint, butane, and propane. These fires usually develop and grow very rapidly. Class B materials are fluid in nature, which allows them to flow and move. This makes dealing with them somewhat more difficult than Class A materials. These materials are common in many settings. These fires typically do not leave an ash. Next, we have Class C and D fires. Classification of fire, US. Class C fires involve energized electrical equipment such as motors, appliances, and machinery. It doesn't matter if the device is turned on or off. If there's power to the device, it's considered Class C. Classification of fire, EU. Class C fires involve flammable gases. This means the extinguisher has an extinguishing agent specifically for gas fires, such as propane, butane, and natural gas. Common extinguishing substances used are CO2 and foam. And finally, Class D and KEF fires. Classification of fire, US. Class D fires involve combustible metals such as potassium, sodium, magnesium, aluminum, titanium, and zirconium. These materials are usually difficult to ignite but create intense fires once started. Class D fires are very difficult to extinguish, but fortunately, they are relatively uncommon in most industries. Classification of fire, EU. Class D fires also involve combustible metals. Class K fires, US, / Class F fires, EU, involve cooking oils and greases such as animal fats and vegetable fats. Class E fires, EU, similar to US Class C, involve energized electrical equipment. Now that we understand the classes of fire, let's look at the tools we use to combat them. Fire extinguishers. Different types of fire extinguishers are designed to fight different classes of fire. The 5 most common types of fire extinguishers are: 1. Water APW. 2. Carbon dioxide CO2. 3. Dry chemical ABC and BC. 4. Wet chemical. 5. Foam. Let's start with water APW fire extinguishers. APW stands for air pressurized water. These extinguishers are filled with ordinary tap water and pressurized air. APWs extinguish fire by taking away the heat element of the fire triangle. Water APW fire extinguishers are designed for Class A fires only: wood, paper, and cloth. It's crucial to remember that using water on a flammable liquid fire could cause the fire to spread. Also, using water on an electrical fire significantly increases the risk of electrocution. If you absolutely have no choice but to use an APW on an electrical fire, make sure the electrical equipment is unplugged or de-energized. Next, we have carbon dioxide, CO2 fire extinguishers. These extinguishers do not have a pressure gauge because the pressure inside is so great that bits of dry ice may shoot out of the horn. Carbon dioxide is a non-flammable gas that takes away the oxygen element of the fire triangle. Without oxygen, there is no fire. CO2 is also very cold as it comes out of the extinguisher, so it cools the fuel as well. CO2 extinguishers are designed for flammable liquids and electrical sources, Class B and CE fires. You will frequently find CO2 extinguishers in laboratories, mechanical rooms, kitchens, and flammable liquid storage areas. A CO2 extinguisher may be ineffective in extinguishing a Class A fire because it may not be able to displace enough oxygen to successfully put the fire out. Class A materials may also smolder and reignite after the CO2 has dissipated. Our third type is dry chemical fire extinguishers. Dry chemical fire extinguishers are filled with a fine yellow powder, primarily composed of monoammonium phosphate. These extinguishers are pressurized with nitrogen. Dry chemical extinguishers put out fire by coating the fuel with a thin layer of dust. This separates the fuel from the oxygen in the air. The powder also works to interrupt the chemical reaction of fire. These extinguishers are very effective at putting out fire. It is extremely important to identify which types of dry chemical extinguishers are located in your area. As per U.S. standards, an ABC extinguisher will have a label indicating it may be used on Class A, B, and C fires. You don't want to mistakenly use a BC extinguisher on a Class A fire, thinking that it was an ABC extinguisher, as it would not be effective for Class A materials. Moving on to wet chemical fire extinguishers. The wet chemical forms a thick, soapy, foam-like blanket over the surface of the burning oil or fat. This stops oxygen from reaching the fire and smothers the flames. Wet chemical fire extinguishers have a yellow label and are designed specifically for use on fires involving combustible cooking media, such as burning oil and fat, Class KF fires. An example of a chemical used for this is FedEx. Lastly, we have foam fire extinguishers. AFFF, or aqueous film forming foams, are suitable for fighting burning solids such as wood, Class A, as well as liquid fires such as burning petrol, Class B. The foam has the ability to creep over the burning liquid or to soak into burning materials such. A common concentration used for this is AFFF 6%. Knowing how to use a fire extinguisher is critical. It's easy to remember how to use a fire extinguisher if you remember the acronym PASS. Pull the pin, break the seal. Aim at the base of fire, not the flames, but where the fire is originating. Squeeze the lever, discharge the extinguishing agent. Sweep side to side. Move the nozzle or horn back and forth across the base of the fire until it's out. Now, let's discuss the rules for fighting fires. Fires can be very dangerous, and you should always be certain that you will not endanger yourself or others when attempting to put out a fire. For this reason, when a fire is discovered, 1. Assist any person in immediate danger to safety, if it can be accomplished without risk to yourself. 2. Call the emergency number or activate the building fire alarm. The fire alarm will notify the fire department and other building occupants and shut off the air handling system to prevent the spread of smoke. 3. If the fire is small, and only after having done these first two things, you may attempt to use an extinguisher to put it out. However, before deciding to fight the fire, keep these things in mind. Know what is burning. If you don't know what's burning, you won't know what kind of extinguisher to use. Even if you have an ABC fire extinguisher, there may be something in the fire that is going to explode or produce toxic fumes. Chances are you will know what's burning, or at least have a pretty good idea, but if you don't, let the fire department handle it. Continuing with the rules. 5 is the fire spreading rapidly beyond the point where it started. The time to use an extinguisher is at the beginning stages of the fire. If the fire is already spreading quickly, it is best to simply evacuate the building. As you evacuate a building, close doors and windows behind you as you leave. This will help to slow the spread of smoke and fire. Do not fight the fire if you don't have adequate or appropriate equipment. If you don't have the correct type or large enough extinguisher, it is best not to try fighting the fire. You might inhale toxic smoke. When synthetic materials such as the nylon in carpeting or foam padding in a sofa burn, they can produce hydrogen cyanide, acrolein, and ammonia in addition to carbon monoxide. These gases can be fatal in very small amounts. Your instincts tell you not to do so. If you are uncomfortable with the situation for any reason, just let the fire department do their job. The final rule for fighting fires is to always position yourself with an exit or means of escape at your back before you attempt to use an extinguisher to put out a fire. In case the extinguisher malfunctions or something unexpected happens, you need to be able to get out quickly. You don't want to become trapped. Let's review how to act in the event of fire. If you are the person discovering a fire, please remain calm and do the following. Call your emergency number immediately. State your name and give the exact location of the fire. If a phone is not available, press and activate the nearest fire alarm. If it is safe to do so, remain at the fire spot to direct the floor and use available means to extinguish or contain the fire. Do not enter a smoke-filled area alone or without protection. Never let a fire get between you and the way out exit. If you are notified of a fire, check with your immediate supervisor. If it is necessary to leave the building, follow the exit signs. Do not use the elevator. If the fire is out of control, then call the emergency number. For a quick reminder during a fire, remember the acronym RACE as part of the fire emergency response. Rescue personnel in immediate danger. Alert, shout, fire, fire. Pull the fire alarm, call the emergency number. Contain, close all doors and windows if there are no other people inside. Extinguish/evacuate, extinguish small fires, evacuate the area. It's a critical fact that most fire deaths are not burn victims. The primary cause of death in fires is smoke. Smoke contains highly toxic vapors such as hydrogen cyanide, hydrocyanic acid, carbon monoxide. Other toxic vapors, trauma, non-burn related injuries, also contributes to fire deaths. Finally, let's talk about fire prevention. Prevention is always better than control. To prevent fire accidents, we have to eliminate the common fire hazards in the work area. These include heat-generating appliances, static electricity and short circuits, non-flame-proof equipment, improper storage and handling of flammables combustibles, open flames and hot surfaces, exothermic reactions leading to explosions, vehicles and equipment, and other unsafe acts and conditions. Fire can be prevented by considering the following issues or points: using flame-proof equipment, maintaining good housekeeping, ensuring proper ventilation, implementing anti-static measures, following clear work procedures and personnel awareness, using inspected tools and equipment, ensuring safe and secured electrical connections, proper storage of flammable and combustible materials, adhering to permit to work, PTW, procedures for hot works, ensuring secured gas cylinders and the use of flashback arresters, spill prevention and cleanup, performing thermography inspection for panels, and many other proactive measures. Thank you for your attention to this vital topic. Please move to the assessment link and submit your responses. Stay safe.